In this video, we are going to use graphical representation to depict the break-even point. As they say, a picture is worth 1,000 words. Maybe that will help us understand the break-even analysis more intuitively, more deeply. On the screen, you have a practice problem. You can pause it and read it. We have to figure out the number of days in a month that Amit has to work to ensure that he does not lose money. When do you lose money? You lose money when you are operating below the break even point. Again, we have to figure out the break even point only. The maximum trips that he can make in a day is 10. So trips per day are 10, and you have price given per trip is 40. This is also defined by the authorities. You can't charge more, and of course you would not want to charge less. The petrol expenses per trip, the variable cost per trip is 10, and you have a monthly rent that you have to pay. This is fixed cost 3,000. That's it. So using this information, we have to work out the number of days in a month that this person should drive the taxi in order to not lose money. So I'm going to do a bit of scenario analysis here, and I'm going to say what happens if I do if I work 5 days a month, 10 days a month, and so on. So let's say if you work 5 days, 10 days, 15, 20, 25, and 30. There are different scenarios, and what is going to happen to your revenue, cost, and so on. So 10 trips a day means you would make 50 trips, 100 trips, 250, and 300. These are the number of trips that you will be able to make as you increase the number of days. Total revenue is going to be based upon the per trip price, which is 40. So total revenue based upon P of 40. So you multiply 40 by 50. So this comes out to be 2,000. And then you have 40 into 100. So this is 4,000. Then you have 6,000. So likewise, we see a slope, same slope, it is going up by 2,000 with every scenario. So 10,000, and you have 12,000. This is the total revenue that Amit will be able to make if he works on different, if he works for different number of days. What is the cost going to be? The cost is going to be dependent upon the two factors, which are fixed cost and variable cost. The fixed cost is 3,000. So if he works for 5 days, 3,000 has to be paid. If he works for 30 days, 3,000 has to be paid. So does not matter, this cost is going to be the same. Variable cost, on the other hand, is 10. These are petrol expenses. So 10 per unit is the variable cost. So variable cost per unit is 10, and depending upon the trips, this is going to change. So you have 500 here, 1,000, 1,500, 2,000, 2,500, and 3,000. Therefore, the total cost comes out to be 3,500, 4,000, and this is 4,500. This is 5,000. Then you have 5,500, and you have 6,000. Alright, so you have all the numbers that are worked out. So now we are interested in figuring out total revenue, total cost. Now we have to figure out the profit. Profit or loss is what we have to figure out. So let me just draw the line here, and maybe these are working notes here. So here you have cost, which is higher than your revenue. So this is 1,500, and this is a negative number. And then you have no profit, no loss. So here the break even. And then you have this is 1,500. Then you make 3,000. Then you make 4,500, and then you make 6,000. This is how your profit or loss situation is changing. Now, clearly, we see that this is 10 days a month. One third of the month is how much this person needs to work in order to start making money. So he should do 11th day and then he'll start making money actually. And number of trips are 100. So 50 trips. So 10 trips a day, which means 100 trips in a span of 10 days. Now, how do we show all of this? And before we go forward, we can also do the algebraic calculation. So, fixed cost divided by the contribution per unit, we can do that as well. So, this comes out to be fixed cost is 3000 and contribution per unit will be P minus VC. So 40 minus this, so 30. This gives you 100 trips. So, mathematically sorted as well. You don't have to worry about the accuracy of this. It has been confirmed. Now, what I'm going to do is I am going to use these numbers to project a graph. And on the graph, I'm going to show the quantity. Quantity is going to be the number of trips that you make. And on the y-axis, I'm going to show revenue and the total cost, fixed cost, variable cost, these numbers. And at this point, at the break-even point, we have total revenue and total cost, which are equal to each other. Before this, you have, before the break-even point, you have total revenue which is less than the cost. After this, you have total revenue higher than the cost. And here you have total expenses and total revenue and total cost equal. So how does it look on a graph? On the next slide, I have only the total revenue and total cost curves drawn out for you. So this is total revenue and this is total cost. So just to make things more clear, this is the break-even point and you have 100 units, 100 trips. This is quantity at break-even point. Now, at this point in time, you have total revenue equal to total cost. Imagine that you are operating at, let's say, 250 units a month, which means you're working more days. So this is the quantity which is actual quantity. So actual number of trips that you do. If you do this, then this is the straight line which depicts this actual quantity, actual level of operations. Now you are operating above. You are operating above the break-even point, and I'm going to the potential, the profitability potential of the business. The higher I go, more profit I earn. All of this, if you were, if you're mathematically inclined to think about such things, then this is the area. If you figure out the area of this triangle, that gives you the profit. So let me write profit. This is the profit. The area of this triangle represents the profit earned. Similarly, if you are operating on the other side, let's say you're operating at 50 units, this is the Q, which is actually the number, actual level of operations, then this represents the loss that you're making. So where do you want to be? Of course, you want to be on the right hand side of the break even level. So, visually it helps you think more intuitively when we say what should be the scale of operations, at what level do you want to operate? Well, I certainly want to operate to the right hand side. That's how you should think about it. And where is that point? That point is the intersection point. So you could simply, do an Excel sheet and prepare a graph and then keep on changing numbers, and we'll do that in the case analysis that we will do shortly. And you could do this scenario analysis very well. So this is the profit and loss region. The other thing that I want to point to is the higher up you are, you keep on going further with every new step that you take, with every quantity that you add, the profitability keeps increasing. See, the profitability keeps increasing. So you want to be as far on the right hand side of the break even point as much possible. And same is, the opposite is true for the loss region. You do not want to be far away. The farther you are, higher losses you are making. Also, mathematically speaking, if you have this equation representing this intersection point of total revenue and total cost, and you have to figure out what is the value of the Q, then you could simply figure out the intersection point. Say total revenue is equal to total cost, and total revenue is P times Q. Total cost is fixed cost plus variable cost times the Q, and you solve for Q and you have fixed cost divided by P minus VC, and this is the equation that we've learned in the beginning of the discussion about break-even point. So again, if you like to think about things mathematically, then simply you draw out these curves and you figure out the intersection point using this formula. Alright, that's the visual representation of break-even point. I'll see you in the next video.